Now that we've got our remote set up, let's look at what's involved in pushing changes to and pulling changes from that remote. I'm back in the Our Clone project repository that we created in the last video, and I'm going to start working on a new feature for the project. I'll create a branch to keep my changes separate, and then we'll edit one of our files real quick and make a first commit. Now we want to show our progress off to our partner, but the changes we just made are in our repository and aren't in theirs, so they can't look. How can we send them back to our remote? The easiest way to go about this is to push our change. The git push command will send all of the changes from our current repository to the remote repository. Let's give it a try. It doesn't seem to do anything. It just says everything up to date. That's because the new feature branch that I just created doesn't exist in our remote yet. Git doesn't know that it needs to be tracking changes in that branch across both of the repositories. I have to explicitly tell it that I want to create that branch by providing the branch name to the git push command. Now we see another error. New feature does not appear to be a Git repository. By default, the first argument to git push, if you provide one, needs to be the name of a remote. If you don't provide one, Git will automatically assume that we're talking about origin. In order for us to provide a branch name, we have to provide the name of the remote first, which is origin in this case, the repository that we cloned from. Then we can provide the branch name. We get a success message. It looks like it finally worked. If we switch back to our other repository and list out our Git branches, sure enough, we see that the new branch has been created. And if we check it out and look at our Git log, we can see that the commit we made is there. Cool. For the sake of this exercise, remember, we're pretending that these repositories are being worked in by two different people. Maybe our imaginary partner didn't totally like our edit to file 2, so they're going to make a quick change and then commit it before switching back to master and continuing on with what they were doing. Meanwhile, back in our clone project, we can do a little more work on file 2 while we're working on our feature. Now, we just made another change to our clone project that we need to share. So just like before, we're going to try to do a git push to send our changes. But this time we get another error message. We're not up to date with the latest changes in the remote, so we're not allowed to push. Remember that commit we made in my really cool project? We need to sync up that bit of project history ourselves before we can try to send other changes. This may seem kind of strict, but Git doesn't know how these different sets of changes are going to merge together. It wants you to go ahead and take care of that first before you send stuff that might be broken to someone else. So, how do we fix that problem? As you might have already guessed, while we have a git push command to send changes to a remote repository, we also have a git pull command to pull changes from a remote repository. So let's give that a shot. The syntax is very similar to git push. We say we want to pull, we specify what remote we want to pull from, and also what branch we want to get the history for. Git tries to pull that information over and, oh, right. In both repositories, we made edits to the same file, and Git has no idea how to fix it. Git pull works pretty much exactly like a merge between two branches, except that instead of merging changes in from another branch, it merges changes in from another repository. And in this case, we just had a merge conflict that Git can't resolve on its own. That's no problem though. We've already learned how to resolve merge conflicts, so let's go ahead and do that. We'll just go ahead and edit the file. Resolve the conflict how you'd like. I think I'm just going to keep the first option since it has my changes. But I am going to be sympathetic to our partner's desire to get rid of excess exclamation points. Now we add our file to the staging area and commit it, just like we would handling any other merge. Aside from that one road bump, our git pull should be complete now, and we're up to date with everything in the remote and ready to try git push again. Sure enough, now it works fine. There haven't been any further changes to our remote, so we can push our history without incident. Let's pop back over to my really cool project. So far, we've done all of our pushing and pulling from our clone project, but let's see how it works over on the other side. I'll just make a quick edit on master, this time to file 1, and commit. And let's try to run git push. We get an ugly error message about no configured push destination. We didn't have to configure anything for our other repository, so what's going on? Remember that we had to specify the name of the remote in certain cases when we were pushing to origin in our other repository. Some cases, though, we didn't. We could simply say git push like we tried to do here. That's because, by default, Git assumes that you're trying to push to and pull from the origin remote. This is how most of your interaction with remote repositories in Git will work. You'll be pushing to and pulling from the repository that you originally cloned from. In some cases, though, you might want to work with different remotes. And in this case specifically, we don't even have an origin remote configured because we didn't clone this repository, we created it from scratch. In order for git push to work, we simply need to make sure that we specify the name of the origin we want to push to. In this case, remember we use the name our clone. Doing the git push while specifying the our clone remote allows everything to go through fine. Pushing and pulling are simple, especially once you're comfortable handling merges. After all you're doing is merging changes just like you would between branches. The only difference is that you're merging project histories across different repositories now. Now that you can clone repositories, set up remotes, push your changes, and pull other people's work from other repositories, you know all the basics of working with remote repositories. Next, we'll take a look at the most popular service for hosting remote repositories, GitHub. But before we dive into that, let's get some more practice in on the basics.